So far in this unit, we have learned how to add and subtract polynomial expressions. We've learned how to determine the quotient of polynomial expressions. We've written and solved linear equations. And this week, we were talking about how to solve linear inequalities. So we have a quiz today. We can prepare for it by looking at the expanded map on the back of our unit organizer. So here, the questions that have to do with linear inequalities is these right here in the pink box. So notice here we have two questions. One is about an equation, which is this first one. Remember, equations have equal signs. And we have a question in this box about inequalities, which is the second one right here. Inequalities have that inequality symbol instead of an equal sign, but other than that, we solve them the same way. The only thing we need to be careful about with inequalities is our special rule that says whenever we multiply or divide an inequality by a negative number, we have to flip the sign. And we will see what that looks like a little bit later on. So I'm only going to look at the question about inequalities for now, but if you want to see how to solve the equation, go back and watch last Friday's video. So here's that problem again, but this time I cut off the equation and I've only given you the inequality. So, like every problem in algebra, we're going to solve it using UPS check. The first thing we need to do is understand the problem and what it's asking us to do. And the important strategies here are to underline and define keywords. So for me, that's that word inequality. And I'm going to define it by saying we solve it the same way we solve equations. The next thing I need to do is I need to highlight my question or highlight the goal for my problem. And in this problem, it's that word solve. That's what they want us to do. We want to solve this problem. And when we are talking about solving, we're trying to answer the question, what is the unknown? So for this problem, our variable is x. So here we're trying to answer, what is x? I've underlined and defined keywords, so now I can go on to the plan portion, or the P, in my UPS check. Here's where I'm going to write down some strategies I'm going to use. So earlier I said we're going to solve inequalities the same way we solve equations. This means we want to isolate the variable. Which means get it all by itself on the left side. And how do we want to isolate the variable? Well, we're going to use things called inverse operations. And this just means we're going to do the opposite of what we see. The very last thing that I would make a note of in my plan is what my answer is going to look like. So in equations, we see our answer as x equals some number. But in inequalities, our answer is not just one number. It's actually a range of different numbers. So here, instead of x equals, I'm going to say my answer is a range of values. So far we've broken down the problem to make sure we understood it by underlining and defining keywords, as well as highlighting the goal. Then we planned how we're going to solve it, saying we need to isolate the variable using inverse operations, and we know we're looking for a range of values in our answer. So now we've done the U and the P, now we're ready for the S. We're ready to solve the problem. I'm going to start by drawing a line straight through my inequality symbol. This helps me separate the left and the right side of my inequality and helps me focus on one at a time. So here I'm only going to focus on the left side, and I'm going to say the first thing I notice here is these parentheses. Every time I see parentheses, I should think multiplying, I should think distributing. So here, I'm going to take the number in front and multiply it to each term inside of the parentheses. So here, I have negative 2 times 3x. And I have negative 2 times negative 4. I'm going to simplify these both a little further. Negative 2 times 3x. I'm going to plug that into the calculator as negative 2 times 3, which gives me negative 6. And remember my variable, I can't leave it behind, it's stuck with me. So I really have negative 6x. Now I can plug in my second term, negative 2 times 4. Negative 2 times negative 4 gives me a positive 8. So I'm adding 8. Remember, if it's positive, we're going to have a plus sign. And if it's negative, we're actually going to have a minus sign. I don't see any more like terms on the left side, so I can't simplify this even further. So now I'm going to jump over to the right side of my inequality and simplify it. Do I see any parentheses on the right side of my inequality? Do I see any like terms? I don't see any parentheses or like terms, so I know that the right side of my equation is actually already simplified, and I can just bring both of those terms straight down. So I have negative 2x plus 10 on the right. And don't forget, in between the left and the right side, we have our inequality, which in this case is greater than. So what I'm left with is negative 6x plus 8 is greater than negative 2x plus 10. The next step, I want to isolate the variable, and I want to make sure that I get it on the left side. So I'm going to do that using inverse operations. Here I'm looking at this negative 2x right there, and I say, well, I want all the variables on the left, so I know I need to move this one to get it over there. I'm going to do the opposite of what I see. So here I see minus 2x. The opposite is plus 2x. What I do to one side, I have to do to the other. Here, negative 2x plus 2x is my zero pair, so it cancels out and it goes away. On the right, I am left with negative 6x plus 2x. So negative 6 plus 2 gives me negative 4. I have a variable, it's stuck with me, can't leave it behind. Negative 4x. And then I'm just going to bring down my plus 8. I haven't done anything with it yet. It hasn't changed, it's still there. Same with my 10 on the right hand side. It's still there, it hasn't changed. And in between my left and right side is my greater than inequality symbol. Next, I have to make sure the variable is all by itself on the left-hand side. Right now I see plus 8. I want to get rid of it. I want to cancel it out. So I got to do the opposite, which is minus 8. Eight minus 8 gives me a 0 pair. It cancels out. And I'm left with negative 4x on the left. On the right, I have 10 minus 8. Which gives me 2. And I still have my inequality symbol between them. So now I have negative 4x is greater than 2. My last step here is to make sure that the coefficient of my variable is a positive 1. And I'm going to do this by dividing by the number in front of x. So I'm going to divide both sides by negative 4. Negative 4x divided by negative 4, that gives me x. And here's where we need to be super careful. This is when our special rule comes into play. Notice how we are dividing by a negative number. Think about how that's going to affect the sign that we have, the inequality sign. Negative 4x divided by negative 4 gives me 1x. 2 divided by negative 4 gives me negative 0.5. But what is my inequality symbol between them? It was greater than, but we divided by a negative number, so our sign needs to flip directions. So now we have less than. So now our final answer, we think, is x is less than negative 0.5. We've solved the problem. The very last step is to check our answer. So here's my check. I think x is less than negative 0.5. But how do I plug this in to an equation? The first thing I ask myself is, can x equal negative 0.5? Well, our answer says no. X is less than negative 0.5. So if we want to check our answer, we have to plug in a number that is smaller or less than negative 0.5. And we can pick any number that we want. I'm going to pick negative 1. And this is the number I'm going to use to check my inequality. So what I'm going to do is I'm going to rewrite my inequality here. But instead of x, I'm going to write negative 1. So that looks like this. Negative 2, then I've got some parentheses, 3x. Well, instead of x, I have negative 1. I like to put my x value inside its own set of parentheses. And this helps me recognize that that is what I'm plugging in. That's the answer I'm checking. I keep going, and I have minus 4, close parentheses, and this should be greater than negative 2x. So negative 2, we're plugging in a negative 1, and then at the very end, adding 10. So here's where I'm going to go to my calculator. I'm going to look at the left side first and simplify it all the way down. Our order of operations, or PEMDAS, tells us to start inside of these parentheses, and we're going to start with our multiplication. 3 times -1 gives me -3. To that, I'm going to subtract 4 and multiply the whole thing by -2. Next up, -3 minus 4 gives me -7. So I'm going to multiply -7 by -2. That gives me a positive 14. I've finished simplifying the left side, so now I'm going to jump over here to the right, and I'm going to do the same thing. First up, I'm going to multiply -2 times -1. That gives me a positive 2. And then I'm going to add 10. 2 plus 10. That gives me positive 12. I have finished simplifying the right-hand side. I'm just going to bring down this 12 so that everything's on the same line. And I remember that I'm checking to see if 14 is greater than 12. So this really reads like a question. This says, is 14 greater than 12? And it is, yes. 14 is bigger than 12. So we know that our answer is correct. But here is where we have to be super careful. We checked x equals -1, but that was only one value inside our range. So what is our real answer? In the plan portion of this problem, we said that our answer should be a range of values. And this is the range that we tested. We checked to see if x was greater than -0.5, and it was. So our final answer for this problem is x is less than -0.5. So there we go. That was how to use UPS check to solve inequalities. Now you're ready for your quiz, or if you think you need a little bit more help, watch this video again, take some notes. If you still have questions, be sure to come to office hours. They are from 1 to 2:30. Other than that, good luck on your quiz. You're going to do great.